Hi, this is Dr. Xu teaching mine ventilation for mining engineering college students. In this video, we will add a fan to our mine ventilation Ventsim simulation model. In an initial mine ventilation design, if the mine layout is determined, we can determine the mine total resistance, and if the mine total airflow is specified by using the square law, P equals to RQ square, we can determine the required pressure to deliver that much airflow. Knowing this initial pressure and quantity can help us find a proper fan. In this Ventsim example, if I click the exhaust shaft fan, click Edit Airways, click the exhaust shaft fan, we can see that this is a fixed flow of 100 cubic meter per second, and the required fan total pressure is 1890 Pascal. We can plot this pressure and quantity and the fan curves obtained from different manufacturers. I have 5 fan curves here, and the pressure here is for fan static pressure. Although we only know the required fan total pressure here, we will use it in this initial stage of fan selection. From the model, plot the flow of 100 cubic meter per second and the pressure of 1890 on the fan curve. It's going to be, so 100 is here, and 1890 is somewhere here, a little bit below this red curve. So it's there. From this point, we can estimate the mine resistance curve looks like this. These 4 fans above this point that we have plotted, they all can meet our requirement. If we install any of these fans, they will operate at the intersection point here, 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 and here. Fan E here will not meet the requirement because it will operate at this point and the provided airflow is less than the required of 100 cubic meter per second. When selecting fans, we need to consider the mine's future needs. With the mine goes deeper, its total resistance will increase and the mine resistance curve will change to this. As we can see, fan B and fan C, in the future they will operate at this point here and this point here. They can only provide less than 100 cubic meter per second of air. So fan B and C does not give us much room for the mine to go further deeper because the provided air quantity will be less than 100 cubic meter per second. Also, if the fan operates close to the end of the fan curve, like here for fan B and here for fan C, the fan efficiency is low, which is not desired. Both fan D here and fan E here meet the current requirement, but the capacity of fan E is too much for the current requirement that will be a waste of fan power consumption. Based on this analysis, we will choose fan D, the purple fan curve, and put this fan curve in the model. The data points from the fan curve has been extracted from the curve. To add this fan to the Ventsim model, click Tools, Fans, Add Fan, give it a name, fan D. There are other parameters here. You will need to put these parameters according to that fan curve. For example, the air density when the fan curve has generated, the speed, the fan discharge diameter, the discharge area, the maximum power, and the reversal factor. We don't have that parameters for the current fan curve, so I will leave them as default. Click here, curve 1. We can add one of the fan curve to this fan D. Because we only have fan static pressure, so click here and put this quantity and pressure numbers in here. If you have the total efficiency curve and the power curve, you can also put it here. Alternatively, we can digitize a fan curve image. Click here and click fan digitizer. Drop my fan image to here. Define the region. In this region, the flow is from 0 to 240. So 0 and 240. And the pressure is from 0 to 2600. Click static pressure. Now I can draw points along this curve. Similarly, you can add efficiency curve and power curve. We don't have that in this example. We're not doing it in this example. Click OK. Now we have this fan curve added to this fan. Click OK. Click Yes. Back to this added airway window from the shaft. Instead of putting a fixed flow, we want to apply that fan. Click here. Choose fan D. This is the fan we just added. Click Apply and Simulate. Now we can see this is the mine resistance curve and this is the fan curve we just added. The current operating point is 107 cubic meter per second. The provided air quantity is more than the designed requirement, which is good. Here you can see the power cost per year. Finally, you can change the electricity price from settings, costing, power. You can put the fan purchase cost here, the mine life, the NPR value, and the power cost. The default value is 10 cents per kilowatt hour, and you can change it according to the actual power cost value. Thank you very much for watching. This is Dr. Xu. If you like the video, please give it a thumb up, subscribe my channel, and share it to your friend who may benefit from this video as well. I will see you in the next video. Bye for now.